Single replacement reactions are the fourth type of reaction that we're going to study. These reactions are the form of A plus Bx react to form Ax plus B. So there is an element by itself on both the products and the reactants, and there's a compound. And during the reaction, the element that is more active can replace in the compound. The first example is where we have a metal replacing hydrogen. This is on page 293. And in this example, you have lithium reacting with water. And if you write it as HOH, it makes a little bit more sense because the lithium is replacing one H. And then hydroxide is a product. So the lithium replaces one of the hydrogens, and then in the products you have lithium hydroxide and hydrogen gas is what's left over. And don't forget the diatomic, as hydrogen is a Brinkelhoff. Second type of single replacement reaction is where you have a metal replacing a metal. And this is much more common than the first type. And you have to do a little work on these. You have to determine if A is more active than B. And you do that by looking on the back side of your periodic table, and there is an activity series. The reaction will occur if A is higher in activity than B. And so we got an example here on page 293. Copper, when it reacts with silver nitrate, the copper will replace the silver, and the products become silver and copper nitrate. But if you go the other way, if you started off with silver and copper nitrate, they will not react because silver is less active than copper. So these are not reversible reactions. They only go one way. The third type of single replacement reaction is when you have a halogen replacing a less active halogen. And the element on top in the periodic table is the most active halogen and can replace a less active halogen. So on page 294, there's an example where you have fluorine reacting with sodium bromide, and the result is that you have sodium fluoride and bromine gas. But bromine does not react with sodium fluoride because bromine is less active. Bromide is less active than fluoride.